some of the safety features we have. Press the double op start and the green light comes on, starting the program. When you press the E-stop, the red light comes on and stops the robot from moving. When the mill is running, the amber light turns on, and when parts need to be refilled, the white light comes on. The MCR on and off controls the power to the control panel. This sign keeps people aware of what's going on inside the work cell, and the physical barriers keep people outside of the work cell. When something triggers the light curtains, the robot stops moving and will continue when you hit the reset. When the E-stop on the mill is hit, the mill will stop running until notified by the operator.
Now let's take a look at the feeders and fixtures on our work cell.
Starting us off, we have the plexi feeder, which will disperse a piece of plexi out for the scorebot to pick up. Now we have the wood feeder, which will do the same thing except dispense out a piece of wood. And now we have the BB ramp, which the scorebot will pick off a BB and put into the maze. Now we have the bad parts bin, which is where all the pieces that don't make it through the inspection station lying next to it go to. This is one of two positions where a maze that has made it all the way through the process will go to. This is the drop chute, and this is the place where the completed maze will make its way out of the work cell for somebody to play. This fixture is the assembly station, and this is where the maze gets assembled at. This fixture includes 3 pneumatic cylinders, 2 of which to push the maze in and out before and after assembly, and the third of which is to push the maze down and make sure that the glue bonds with the plexi between the wood and the plexi. The inspection station is the determining factor in whether or not the maze is good enough for somebody to use or it's trash and should get thrown away. It has 4 sides for a perfect fit inspection and includes a limit switch to tell the robot whether or not it has been triggered and should get picked up. Finally, we have the mill vise. What this allows us to do is to keep the piece of wood in place while it is getting milled so it doesn't go flying all over the place. It nests the wood in a corner so it doesn't move.
Now to talk about inputs, outputs, and valves.
This is our control panel. On the left we have the circuit breaker, which everything including the MCR is run through. The yellow wires are input wires and the green wires are for outputs. The air hoses run to an air pressure gauge on the top of the control panel. All the wires also run up to the top of the control panel where lights and push buttons are located. This is where all the wires from the control panel run down to. They are wired into the controller. Over here is where we have the ground wires daisy chained together. Over here are different relays that are wired into the valves.
This is our 24-volt power supply. It powers half the valves in our valve board, and the other half are powered by the controller. The valve board controls all of our pneumatics on our work cell. It also controls one special vacuum gripper.
This is what the program looks like typed out on paper. This is our documented program. It features positions on each page, and it also features labels and subroutines that the scorebot can jump to throughout the program.
Here is the robot running through the program.